and gentlemen, welcome back for another round. This is Mr. Doolin. I thank you for tuning in. Today we're going to jump right into it. We're going to take a look at percent yield. Percent yield's not a difficult topic as long as you are competent in stoichiometry. And I guess if you wanted an actual definition of percent yield, you would think of it as it's going to tell me the percentage of what I actually got versus what I should have gotten. So if we think of percentages, we think of part over whole times 100%, and that's going to give me my percentage, right? This is going to be my percent yield. Now, when I look at my part versus my whole, the thing that I'm going to look at is that my part is going to be what I actually got or recovered from the particular reaction. My whole is equal to what I should have gotten. All right? And so a lot of the times, if you want the proper vocabulary here, the what I should have gotten, this is actually referred to as my theoretical yield. And it is a calculated value. What you actually got, this is also, the technical term for this is your actual yield. And so not to overcomplicate this, we could just take this, what I actually got over what I should have gotten, and then we can write a definite technical definition here and say that it is actually, percent yield is actual yield over our theoretical times 100%, and that's going to equal my percent yield. And that's just my very ugly percent sign there. All right? And so don't overcomplicate this, ladies and gentlemen. My theoretical yield, this is going to be a stoichiometric value. So I'm actually going to use stoichiometry to calculate that value, right? Because all of stoichiometry technically is a theoretical value because it's happening on paper. It's not actually happening in a lab setting. My actual yield means that I went and I actually did the experiment, and then I recovered, and this is what I actually got out of the experiment, all right? So if you think about when we're sitting down taking tests and we're doing these worksheets and these problem sets, then you understand I can't actually put you back in the back and have you do the actual yield. It's something that I've got to give to you. But the theoretical yield, I can make you calculate all day long. All right, and so what I've got now is I'm going to do an example with you just really quickly. So in this particular case, let's say I start out with 25 grams of carbon disulfide. And I'm going to go and do this reaction. I'm going to combust it. It is a combustion reaction. We see that because of the oxygen as the reactant. So I'm going to combust this, and then I'm going to go ahead and tell you, hey, I recovered in this reaction 40.5 grams of sulfur dioxide. So I reacted 25 grams. I actually recovered 40.5 grams of that particular product. So the question becomes, this I automatically see as my actual. Right? That's my actual yield. That's what I actually got out of the reaction. So my theoretical yield, what I would do is I would take the amount that I've got here and I would convert it to grams of the product that I'm interested in. And so I'm not going to do this stoichiometry for you. I'm just going to say 25 grams, and I guess I'll just put the molecule there, of CS2 is going to produce, theoretically, 42.1 grams of sulfur dioxide. And so this represents my theoretical, that's right, my theoretical yield. It's a stoichiometric value, all right? So then actual divided by theoretical, I would do 40.5 grams of SO2 divided by 42.1 grams of SO2 times 100%, and I would see that that would be a 96.2% yield. And so what percent yield tells me is that essentially this reaction, it's almost a measure of reaction efficiency, is that this reaction was 96.2% efficient at producing the product that we were actually recovering. All right? Okay, so not anything complicated or crazy, ladies and gentlemen. What I expect you to get out of here is what percent yield is and how I recognize that I need to do it. So make sure that you understand the nuances of what I went through with this particular example. All right? If you have questions, get them down. I'll see you in tutorials for those. Otherwise, I will see you in class.